All right, here we go. Last chapter of the school year, 15.1, statistical measures, a calculator, almost a must in this situation. Let's take a look, if we will, at 15.1, 15.1 part 1. If we take a look at this, we're going to be talking about these are somewhat familiar to you. We're going to be talking about a mean, okay? And the mean, obviously, is one of those that's a measure of center, and it's a value that simply is known as the average, really, is the synonym for it. So what you're going to do is you're going to take a data set, and in this case, we have, 3, 6, 7 pieces of data. You're going to add all the data numbers up, and then you're going to divide by the number of data sets that you have, or data values that you have. So right here would be the Bible verse for you to calculate mean, okay? And so in this case, when they added all those up, you could do that on a calculator if you wanted to. One thing I would ask of you is, once you get to that 9, hit your equal sign, and then divide it by 7. If you do not do that on a scientific calculator, the only thing it's going to do is take the 9 and divide it by the number 7. Okay, so be careful with that. All right. If I have an odd number of data values, we're going to be talking about the median now. Median simply means middle. And so one of the first things that you have to do is you have to line up all the numbers, smallest to biggest. All right, and they already did this for you. And so if you have an odd number of data points, the good news is there is a true middle. And we know this is a true middle because if you look, we have 3 numbers to this side of that middle number. We have 3 numbers to this side of that middle number. And therefore, the median is another measure of center. All right. If I give you an even number of data points, so in this particular case, you see I have 1, 2, 3, 4, 5, 6, 7, 8 data points. That means there are actually 2 middles. All right, and we could get to the middle by simply crossing off, start at each end, off 1, off 1, off 2, off 2, off 3, off 3, and that leads you to the middle. So the middle is the 6 and the 7. So all we're going to do is take the average of that 6 and 7, and in order to do that, all we're doing is adding those 2 numbers together, dividing by 2, and so that's telling us that the median of this is 6.5, okay? So that's what we're looking for. We're going to be talking about 2 measures of center. Mean, which is probably the one that you're most familiar with, another name for average, and then median is the middle number. Key player there is, on the median, you've got to line the numbers up, smallest to biggest. Moving on to my next example. It says here, as you can read, we're at Yellowstone National Park, and in this particular case, you have to find the mean and the median intervals between the eruptions. So the first thing that we would have to do is identify, hey, this is a 6, 7, 8, and 9. And so I'm going to look at it and say, all right, if I go left to right, and this is the nice thing about a dot plot, is if you just go left to right, we're at what, 5.5, we're at 6, we have 2 numbers at 7, and you have to put both of those down. We have a number at 8, we have a dot at 8.5, and we have 2 dots at 10. Okay, so the first thing it says is we want to find the mean. Okay, so with the mean, what are we going to do? We're going to add all those guys up. So if I take 5.5 plus 6 plus 7 plus 7 again plus 8 plus 8.5 plus 10 and plus 10 one more time, I get a total of 62. Okay, so we're calculating the mean right here in red. Okay, I get a total of 62, and so I take that 62 and I divide by the number of data points, which I have 1, 2, 3, 4, 5, 6, 7, 8. You can also look on the graph and see 2, 4, 6, 8 that you have 8. So 62 divided by 8 is going to be 7.75. 7.75. So the mean is 7.75. Okay, 7.75 is the mean. How about the median? All right, same piece of numbers, same set of numbers. All right, I'll switch colors here with you, and I'm just going to really recopy those down. So I'm at 5.5. I'm at 6, 7, 7 again, 8, 8.5, and 2 10s. So I have 8 data points, which we figured out by calculating the mean. That means there's 2 middles, all right? My 2 middles are going to be what? I'm going to knock out this guy, this guy, this guy, and this guy, this guy, this guy. So that means my 2 middles are 7 and 8, and the average of 7 and 8 are 7.5. So that means that my mean, or sorry, my median is going to be 7.5, and my mean is going to be 7.75. Using the measure center, what inference can you make about how often the Joule geyser erupts? It appears as though Joule geyser erupts, somewhere between 7.5 minutes, every 7.5 minutes to 7 3/4 minutes. All right. Okay, move on to my next example, or my next point that they'd like to make. And so the next point we'd like to make comes up from the got it during eruptions. Water soars up certain heights. What is the mean height of the geyser eruptions? Again, since we're looking only for mean, there's no need to put them in order. So I would just go left to right, 15 plus 30 plus 27 plus 23 plus 28 plus 19 plus 11. Ooh, I skipped 14, plus 14 plus 22. Now I want to hit my equal sign. I'm at 189 there, I believe. And I'm going to divide it by the number of data points I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 data points. So 189 divided by 9 equals 21. So that means the height, average height of the geyser is about 21 feet. So my correct answer should be C. Okay? All right, move on to part 2. And let's see what we got going on part 2. Come on, part 2. All right, this one we're going to be talking about measures of variability. Okay, so the measures of variability is a value that describes how far the spread is in terms of the values of the data set. Okay, so if we take a look at the range is simply going to be the biggest number, biggest point given to you minus the smallest point given to you. So the max value minus the minimum value, and in this case, and this is not always going to be, in this case it happens to be the first and the last number. That's not always going to be the case. What's the difference between -5 and 11? So I'm going to take 11, I have to subtract it, and I'm subtracting this entire thing in the circle, so I'm subtracting -5. So that's the same thing if you remember Chick Boom way back when. That's 11 plus 5, which is what? 16. So our range here is going to be 16. Okay? If we talk about quartiles, quartiles are the spread of the values in the data set. And so the one thing that they did not do, well, yeah, they did. They have to put these in order. When we're talking about range, we're talking about quartiles. You again have to put them in order. And so they are going from smallest to biggest, okay? And just to share with you how, since we have 7 data points, right here is the second quartile, all right? The second quartile is also known as the median, okay? Second quartile is known as the median. So if you find the median, you just found the second quartile. That leaves you with 3 numbers to the left of that and 3 numbers to the right of that. And you can see in this situation, the first quartile is going to be, it's kind of like saying, what's the median of the lower half? Well, here's the median of the lower half because it's the middle number in that set of 3. That's the first quartile. Here's the middle number in the higher set of 3. So our first quartile and our third quartile are going to be that -1 and that 8. Okay? And then obviously when we talk about the interquartile range, often referred to as the IQR, then you're simply going to take the third quartile, right here it is, third quartile minus the first quartile. So in this case, it's 8 minus -1. So the range there, the IQR, is 9. Okay? All right. So let me get out of there. Go to our example problem here.
Now this is what I call an adventure. No data needed. That's a fact.
All right, so they already made the box plot for you. That's something we would have done here in class. You know, we would have practiced working on making box plots from things like our heights or something to that effect. But so we're going to find the range and the interquartile range of the temperatures. That's the first thing we want to do. Well, it appears as though, you know, we're talking about range. We got to figure out about what number do you think that is, and about what number do you think that is. Okay? So the range, remember, is the largest number, largest minus smallest, largest minus smallest, and in this case, I'm going to guess that the largest is about what, 202 maybe? And the smallest is about let's call it 144. All right, so we should be pretty close here. So 202 minus 144, 202 minus 144 is about what, 158? No, 58. So our range is 58, we think. We're pretty close to that. Should be somewhere in that neighborhood. Hard to get specifics because of the way it's set up. And then the interquartile range, again, this nice thing about them having the box plot is the length of the box, right? So right there's the first quartile, right here's the third quartile. And so the length of the box represents the IQR. So you might want to know that IQR is length of box. And it is the third quartile minus the first quartile. So we're looking at what, about 188 minus about 155, 156 maybe. So we're saying that our interquartile range is going to be about 32. Okay? Let's see how close we are. We said 58 and 32. And so you can kind of see, look at the picture and see that the spread here, if we're looking at each of these as a quartile, like quartile obviously means a fourth. So if we looked at this as a quartile, we could look at this as a quartile. Here's a quartile, which means again 1/4. And here's a quartile. There's our four pieces. And you can see that those four pieces are really, in terms of the length of them, about the same. And so when they're about the same, that tells you that the variability of them is pretty consistent. Okay, let's take a look at what their solution is here. They said max of 201, 144, so they're at 57, we're at 58. They said that we have a 189 minus 155, which they said is what, 34, we said 32, so we're close. And so basically we're saying that the temperature in the hot springs are spread out evenly throughout the data set, okay? Which is pretty much what we stated without their help. All right, let's take a look then at my last example problem on part 2. And it says, what's the IQR of the depths? So once again, if we take a look, first thing we have to do when I'm talking about IQR or range, I got to put them in order. So I'm going to go 6. I'm going to cross them out as I go so I don't forget. I'm going to go 23.5. I'm going to go 225. I have 2 of those. I'm going to go 27. And I'm going to go 32.5. Okay? So based upon what we know so far, we have 1, 2, 3, 4, 5, 6 data points. Okay? So that means we have 2 middles. So if we have 2 middles, we're going to try to identify those as, well, it's pretty obvious here. These are my 2 middles. So that means that my median would be 25. That's also known as the second quartile. Okay? We have to find, so then what we would do, and again, there's a little discrepancy here between certain math systems, but the question becomes, some people claim that the next quartile could be found by saying, all right, we have these 3 pieces, and we have these 3 pieces. So they're going to say that this is 23.5, which is the first quartile. and they're going to say that this is the third quartile because it's the middle of that bigger box, that blue box. And so they're going to say that the third quartile is 27. So they're saying the IQR is 27 minus 23.5, which would be 3.5. Okay? I'm going to be a little interested to see what they say here. 3.5 is on there. Cross your fingers. 3.5 it is. And I say that because there's some math systems who basically would take a look at this back half and say, once you've eaten up this 25, you only have these two numbers left. Once you eat up those 25, you only have these two numbers left. So they would take the average of this and the average of this and then subtract those two. So we have to be a little bit cautious, or at least aware of how Pearson plays it. It appears as though in this case Pearson plays the way I initially thought, which was once they determine that this was 25, they break this into, okay, my 6 numbers now have 3 numbers and 3 numbers, okay? Which makes sense. All right, moving on to part 3, our last and final part. This is going to be story problems. So here's the situation. You have to find the median and the range for each airline. Based upon the two values, make an inference, which is basically an educated guess, about which airline they should choose, justify your reasoning. All right, so in this case, we are looking at, let's take a look at beta. All right, so in terms of beta, I'll use red for those guys. We're looking at the median and the range. So the range is, right there's the biggest number, and the smallest number looks to be right here. So I'm going to take 722, and I'm going to subtract 399. So beta has a range of $323. Okay, its median, so they want that right there. Its median is the middle number, and the middle number looks to be, there's the biggest, there's the smallest, next biggest, next smallest, looks to be 402. So the median here is 402. Over here with Park Air has a range of, looks like the biggest number is 465, and the smallest number is what? 398. So we're going to take 465, and we're going to subtract 398, and that equals 67. Okay, so the range for Park Air is 67. Range for Park Air is 67. And the median for Park Air is going to be the middle number. We already have, this is the smallest and this is the biggest. What's the next biggest one? 447. What's the next smallest one? 409. So it looks like right here is my median is at 428. Okay. So the question is, once you've found those numbers, make an inference, make an educated guess about which airline they will most likely choose and justify your reasoning. Okay? Well, it looks as if, wait a sec, what did I do wrong here? The range can't be 323 on beta. The range has to be what? Yeah, it is 323. Okay? So you have to make a determination. And now, obviously, the median on the blue one is larger than the median on the red one. So if you're just going to look at the median, then obviously most people are going to choose the beta. But please understand, look at the range. The range is $67 on Park Air, and on beta it's $323. So it is quite possible that you would get the high end of this. And so if you're trying to play it safe, I think I probably would take Park Air over top of beta. And the reason is because you could get this monster big $722 bill, as opposed to the biggest one you could get on Park Air is what? 465. Okay? All right, let's see what they have to say about that. So they came up with the same numbers we did, 67 and 428. The range on the flight prices is 67. So the inference is the median's not affected by stray values while the range is. Unusually high price on the samples of the median. So sample might be the median price of beta is lower than the median price of Park. So Misadventure and Data Girl might choose beta. Okay. Again, I think you could argue both sides in that situation. All right. Anything else for the good of the cause? If not, microphone just fell on the floor there. We're going to shut her down. Thanks and have a great day.